Okay, we're going to talk about 3.3, which is corresponding parts of congruent triangles are congruent, and applying that principle after we have proved triangles congruent. And then we are actually going to be reviewing some basic properties of circles because we should already know a good amount about circles. So what does CPCTC stand for? We've been proving triangles congruent the last couple of days. So once we get triangles congruent, we are only using 3 pieces of corresponding information. We can prove it by a variety of different ways. After we prove triangles are congruent, we have 3 parts that are left undone. So once we can get them congruent, we can say that corresponding parts of congruent triangles are congruent. We can get the other 3 corresponding parts to say they're congruent, because once we get the triangles congruent, we know that every part of them are congruent. So if we look at our first example here, if triangle XYZ is congruent to triangle MNO, is that true? Angle Z is congruent to angle O. So if we can just look at the angles in their spots here, Z is in the same location as a corresponding location in the 2 triangles. So yes, it is true that those are congruent to each other. We'll look at our next example. First off, what triangles could we prove are congruent? So if we label our given information and we mark our reflexive property, we can first say that triangles SMW and triangles PMW are congruent to each other, and we have that by SAS. We have parts that are not mentioned here now, so we can say that those other parts are congruent going beyond just the triangles are congruent. We have angle S could be congruent to angle P by CPCTC. And I'm going to put in some numbers here. We could also say that angles 1 and 2 are congruent. Those are other angles that are in corresponding parts, corresponding locations. And then we also have segments, the last pair of segments together. We can say that SW is congruent to PW. And these are the 3 parts that are left over, so we can say that they are congruent by CPCTC. Talk about circles. This is the symbol for multiple circles. It'll tell you what is the center of the circle. And every point of the circle is the same distance from the center, and the center obviously cannot be part of the circle. So some of the things that we know about circles, we should know that this is area, and we know the formula for area is pi r squared. And this is for circumference, which is pi times d, or 2 pi r. And the d stands for our diameter, which is 2 times the radius. And when you have circles, it'll tell you that you have a circle with center P. So this tells you that P is the center of the circle. It might also tell you something with multiple circles if it says circles in the middle here with P and R, that P and R could be the centers of your circle if you have multiple circles. And then your if-then statement for using this is if you have a circle, then all radii are congruent. So our first proof here, if we want to first label what we have given, we have angle S is congruent to angle P. We are also going to get a pair of angles congruent with our second given information. So I'm going to mark those as angles 1 and 2. We will be able to prove 1 and 2 are congruent. And so now we're down to needing one more piece of information, and I can see that we are sharing a common side here. So in order to write that as a proof, let's start back at the beginning. So we'll start with angle S is congruent to angle P, which is given, and that gives us an angle. We also have that MW bisects angle SMP. This gave us in our diagram that angle 1 is congruent to angle 2. Because if a ray bisects an angle and divides the angle into two congruent angles, that gives us another angle. And then as I marked in the diagram, we have a common side, so we need to list that reflection side. And then to verify, we have our three things marked in our diagram, and the three things correspond with angle, angle, side, so we can prove the triangles are congruent. And the steps we got from angle, angle, side are 1, 3, and 4. And once we prove the triangles are congruent, we can say that the corresponding parts that we want to be congruent are by CPCTC, and that came from the triangles we proved congruent in step 5. All right, moving on to the next example. So when we look at this one, we have a circle here. This tells us that O is the center of the circle. So then we can say that any of the radii are congruent. We first need to say that we have circle O, and that is a given. And then this specifically gives that radii are congruent. So go with OM and OP are congruent. Tells us that they are congruent. Next piece of information gives us perpendicular. Now we need to get the congruent statement, but perpendicular in our diagram we have right. So I'm going to put in a 1 and a 2. And then we can say that angle 1 and angle 2 are right angles. The perpendicular leads us to the right angles. That is not a congruent statement. We still need to get the congruent statement. So after that, we can say that angles 1 and 2 are congruent to each other. And the reason is right angles are congruent. Now we have two pieces of which is a reflexive side. Now we have our three pieces of information in our triangles are congruent. So we can say that the triangles are congruent, ROM and ROP. The reason is from SAS, and it came from step 5, step 2, and step 6. And once we say that the triangles are congruent, we can then say the leftover parts we want that are in corresponding locations are congruent to each other, which are MR and PR. In the next proof here, so if we were to first start off with the fact that we have E is the midpoint, what does E being the midpoint tell us? It tells us that we have two segments that are congruent. We know that if a point is the midpoint, it divides the segment into two congruent segments. That gives us one of our pieces of information. Look at our next given saying that 1 and 4 are congruent. 1 and 4 being congruent does not currently give us anything that is in our triangle. But I can see that the angles that are right next to them point to there first. So I need to pick two separate triangles, angle ACE and angle HJE, straight angles. And that is assumed because once I say the straight angles, I can say that two angles are supplementary to each other, 1 and 7 and 4 and 6. Because if two angles form a straight angle, and they are supplementary, and so then once I get the two angles are supplementary, two congruent angles, I can say that I have 1 and 4 are congruent. So I can say that the supplements are congruent, so I can say angle 7 is congruent to angle 6. And so now I have a side so far, and I have an angle. Another piece of information that I can take from the diagram is I can see that angle 8 and angle 2 are vertical angles. That the first are vertical. That's something we can assume from the diagram. After I say that they are vertical, I can say that they are congruent to each other. If the angles are vertical, then they are congruent. I now have enough information to say they're congruent in the order I have is angle to angle. So I can say that DEC and FHA. And the steps I got for that were 6 to 8. Now that I've said the triangles are congruent to each other, I can say that my leftover parts are congruent by CPCTC. As you can see, the proofs can start to get a little bit longer now. We need to make sure that we have 3 corresponding parts congruent all the time. We complete number 4 as a flowchart, and we will do number 5 in class together, so you do not need to complete this one tonight, but please complete number 4. We'll check it in class and then do number 5.